Start off here with 2H2O. So when you see the 2 out front, this 2 is telling us how many molecules there are. On your worksheet, you're going to first have to figure out how many molecules of something there are. Then you're going to go into each individual atom. So in this one, we have a hydrogen and we have some oxygens. And so let's figure out how you would find each of these. So when you're looking just at the molecules, you're looking at the coefficient out front. So if there is a 2 out front, that's going to be how many molecules there are. The 2 also means like you're just writing out H2O twice. You could do that and then count up your H's. You see there's 4 there and then there's 2 oxygens. You could do it that way. You can also just look at the formula and see there's 2 right here. That 2 would get multiplied by the coefficient, so 2 times 2 would give us a total of 4 hydrogens. And then on the oxygen end, there is no coefficient following the oxygen, so that just means there is 1 right there. And then 1 times 2 would give you 2. And that's what we got over here too when we did it that way. So either way is totally fine. The next one would be 3 total molecules of Na2SO4. So like we did before, you're first trying to figure out how many molecules there are. After that, you go into each individual atom. So we got sodium in here, sulfur, and the O for oxygen. Now, when you're looking at molecules, you're only looking at the coefficient. So I see that there are 3 molecules here. Then we will get into sodium. Sodium is Na. I see a little 2 right here. So that means there's 2 sodium atoms normally in this molecule, but we have 3 total molecules. So you'd write Na2 3 times. By doing that, you would have a total of 6. It'd be like going 3 times 2 for a total of 6. Sulfur. Sulfur, we're looking right here. There's no coefficient after it, so you can imagine there's a 1 there. If you have 3 total molecules here, you'd be writing that S 3 times if you rewrote this formula 3 times. So in total, you have 3 sulfurs, 1 times the 3 out front. Oxygen, normally you would have 4 in a single molecule, but you notice that there's a 3 out front. So you go 4 times 3. 4 times 3 is going to give you 12. All right, there's 2 down. Now let's go to lead. So you'll see PbNO3, and you got 2 of those NO3 polyatomic ions. So right here, you're starting off again with molecules. Then you go into the individual atoms. Pb, you got a nitrogen there. And last but not least, oxygen. With the molecules, look at the coefficient out front. I see there's a 4 there, so put a 4. With the lead, the Pb, there is nothing following it, so there's just 1 there. So 4 times 1 would give you a total of 4 of these leads. Now we're getting inside the parentheses. If you look inside, there's only 1 nitrogen atom in there, but you do have to multiply that 1 times 2. So you'd originally go 1 times 2, and you'd get 2. But we can't forget about the coefficient out front. That means we would have to multiply this answer by 4. 2 times 4 would give us a total of 8 for our nitrogens. Okay, and then we get into oxygen. Oxygen right here has 3. If you go 3 times 2, you're going to get to 6. So you would first go 3 times 2 and get 6. Then you got to multiply by that coefficient out front. So keep your 6 and multiply by 4. Whoop. And that's going to equal 24. Awesome. And then we got 1 more left, our magnesium hydroxide. So magnesium here, we're first looking for molecules. Then we'll go magnesium, oxygen, and hydrogen. Remember, Mg is 1 single magnesium atom because it's a lowercase g. If you had a capital M and then another capital letter, then that's 2 different atoms. But in this case, it's just 1 atom of magnesium there. So starting with molecules, I do not see any coefficient out front. So 1 molecule. Mg, there is nothing following the Mg, so we just say there's 1 there. Oops, get rid of that one. Whatever. Oxygen in here, you have OH inside the parentheses. It would just be like writing OH twice. If you wrote OH twice and counted up your oxygens, you'd have 2 of them. If you counted up your hydrogens, you'd have 2 of them. Or you can just distribute out this 2 like so, and you'd have 2 oxygens and 2 hydrogens. And there are the first 4. Hopefully that gives you a good start. Let me know if you have questions on the other ones. I would love to help you out, but good luck.